And welcome to the Daily Space Weather Smash Show here, coming at you once again from the Smash News Network, least busted name of news. Just bringing the most detailed imagery you'll find anywhere in the sun and the most comprehensive space weather imagery in the world. We've got a lot of frames of the closest star to show you today, so let's not mess around. Fantastic aesthetic setting of some active regions there in the southwest. Also a rising of at least 3 new sunspot groups in the northeast. Huge filamentary activity associated with those rising regions as well. It's a filament fest. Make sure you join us on Twitter at SmashOmash if you'd like to name filaments after living people. We're also looking at naming coronal holes after land masses. Seems like a logical choice. So check out the Filament Fest. 193 plus 304 angstroms is a great comprehensive pair of wavelengths to view filaments. Let's take a look at the northwestern limb first. Some prominence is happening up there as we view the active sun. Not shutting down, and a long way, a couple of years out from solar max. Here is the southwestern limb. Some prominence is happening down there again. Also huge filaments, some of which have grown since yesterday, perhaps making them more likely to eject and be associated with flares. Next, the southeastern limb. Prominence is down there. Coronal mass ejections showing up in the imagery. You can see that one prominence, a filament hanging off the edge of the solar limb. Eject. Some of it splashes back down, some of it ejects. We'll show you more information on that later. Is it headed toward Earth? We'll let you know. And this new prominence up here, this is probably the second largest filament at the moment. It is quite spectacular. So new active regions rising there in the northeast. And let's take a brief moment to look at Croissant Earth. How about sunspots first? And let's take a brief look at sunspots first. So there's the current situation, hundreds of sunspots at the moment. And we can expect the sunspot number to actually rise today because, again, there are 3 new sunspot groups that just rose. Also a little bit of evolution happening there in the existing sunspot groups. No major changes happening. A little bit of growth in both of these groups here. And this is the place to watch, folks. This area right here. There is a bridge of plasma stretching across the solar equator, suspended by the magnetic fields of those 2 massive sunspot groups. Don't be surprised to see an X-class flare and an Earth-directed coronal mass ejection from those areas. There you can see a bunch of active regions there rising in the northeast, and let's take a look at planet Earth here for a brief moment and see what volcanoes are erupting. Shiveluch is on the list. It's producing a 23,000-foot plume of volcanic ash over the Kamchatka Peninsula. Sakurajima, 7,000-foot ash plume over Kyushu, Japan. Suminosejima, flight level 050, that's a 5,000-foot ash plume over the Ryukyu Islands. Semeru exploding, flight level 140 over East Java, Indonesia. That's a 14,000-foot ash plume. Kilauea continues its effusive eruption. And by the way, this image right here, that is the Halema Uma'u lava lake. As Kilauea continues to rather quietly effuse more real estate as Hawaii continues to grow physically. Popocatépetl exploding, flight level 220 over central Mexico. It's a 22,000-foot ash plume. Headed down to Guatemala, Fuego exploding, flight level 160. Nevado del Ruiz exploding in Colombia, flight level 220. In Ecuador, we've got 3 of the usual suspects, Sangay, Revenador, and Cotopaxi, all exploding. 22,000-foot ash plume over Sangay, 14,000-foot ash plume over Revenador, and a 25,000-foot ash plume over Cotopaxi. And we're unable to detect whether or not Sabancaya is erupting. If you're going on a volcanic vacation, leave your vault pole at home, because we'd prefer if you didn't pole vault the caldera. Next, looking at earthquake activity here. It's been pretty calm over the past 24 hours, although the past 2 weeks have been pretty active with multiple 7-magnitude earthquakes. That's the past 90-day bar graph. And let's scroll up the list here. We'll cite earthquakes over a size 5 magnitude. So there we go. 5.1 at Malta. We covered it yesterday. We're coming at you a little earlier, I guess, today. .5 at Indonesia also, and a 5.1 at Indonesia. I believe those are actually, are those aftershocks? I don't think those are aftershocks. Anyway, let's continue on. And if we miss anything, let us know in the comments. We only view Volcano Discovery and USGS's information here. And there was a 5.0 at Greece. Not the most uncommon area for earthquakes. So quite calm here. Not a lot of quakes, and certainly not any big quakes over the past 24 hours. Let's get back to space. Here's another great composite. This is 131 plus 171 angstroms, great at showing flares and magnetic looping. You can see plasma there oriented to magnetic fields. And let's take just 171 angstroms by itself to show the lower corona. That is ionized iron, part of the extreme UV portion of the ultraviolet spectrum. And the 10.7 centimeter radial flux has dropped down to 220 solar flux units. There is the 1-year graph. To put it in context, the black line is the radial flux. As you can see, we recently reached new peaks for solar cycle 25. For everybody praying to be right about a grand solar minimum, sorry, when all of the data refutes your hypothesis, please abandon your hypothesis because it is clearly incorrect. Next, looking at the Space Weather Enthusiast dashboard here, and NOAA's forecasting a little bit of geomagnetic unrest later today. Not sure what the reasoning is. Rationale, due mainly to the combined solar energetic proton event probabilities of active regions, there is a slight chance of S1, minor solar radiation storm. Oh, they're talking about a radio blackout there. That's not talking about the KP4 that they're forecasting. Anyway, some geomagnetic unrest forecasted there by NOAA. Nothing major, and nothing apparently major on the way. Is there a CME headed this way? We'll let you know later in the video. KP is currently at 3. The KP index, a planetary K index as it's otherwise known, is a measurement of global geomagnetism, and we are in geomagnetically calm conditions. Here's Earth's magnetic moment from space for the past 4 hours. And we do see some variations in the solar wind. That's what's causing those perturbations to happen there. We've had some instrument changes, and keep in mind that is a model. Next, the last 4 hours of Earth's magnetic moment from the ground. This will show you the most likely places for aurorae, and we've shared some auroral imagery on the Twitter feed. Yet another reason to follow us on Twitter. That's Earth's magnetic moment from the ground, and let's take a look at the real-time solar wind next. Now, if you look at this bottom line, you can see some blue and some yellow. That's an indication that the Discover is being used. And then right here at the end, you can see it switches to the ACE. It turns green. So that's the changes there in the solar wind. So the current conditions as measured by ACE are 387 kilometers per second for the solar wind speed, solar wind density 2.6 protons per cubic centimeter. It is quite clear out there in space here at the moment. It is calm in terms of space weather. GOES magnetometers here showing some rather low highs and rather low lows, actually. If you look at the 7-day graph, it might be more obvious. Little tight range there for the past 24 hours. And let's take a look at the heliospheric current sheet next. This data is from 51 ground-based magnetometers, also magnetometers on stereo A and on stereo B. So almost the entire north solar polar field is oriented toward the Earth at the moment. Welcome to the North Pole heliosphere. You are currently there. And most of the north solar polar magnetism is currently directed at the Earth. Check out the line of sight field plot. The sun's B field here looking like it's fanned out. That is because, in many ways, this is showing you the magnetic equator of the sun at the moment. As the field reversal process happens, the magnetic fields cross the equator as they're doing now. We've got coronal holes. So let's take a look at those next. The main feature of the solar polar field reversal process, and it's how we monitor that. So there you go. Lots of green there on the Earth-facing portion of the solar disk. A tiny bit of red down here. Why? Because that South Pole coronal hole is at the South Solar Pole. Because we've got a long way to go to get to solar max, as we've been saying for months, despite a lot of, shall we say, less than creditable sources stating otherwise on YouTube videos. So let's take a look at coronal holes here from SDO's perspective. So interestingly enough, South Solar Pole still at South polarity magnetism still here at the South Solar Polar region. We've got North Pole coronal holes galore on the rest of the Earth-facing portion of the solar disk. Which brings us to sunspots. So we've got lots. And when I say lots, I mean hundreds. And we're going to have 3 more named groups, at least. 1, 2, 3. That'll be 3197, 3198, and 3199. That's a lot of sunspots. So we'll have the sunspot number rise today. Also, the radio flux may rise. We'll have to just watch that. I suspect the radio flux is going to rise a little bit. Whether it'll reach new highs remains to be seen. I don't think so. Let's take a look at sunspots here from SDO's perspective. So there's ionized helium. That's 304 angstroms. One of the classic wavelengths. As the filament fest continues, it's been an exciting couple of weeks for solar activity. So there's our SDO continuum imagery. And let's get a little closer here. That's a little bit too far zoomed out. There we go. Again, 3 new named sunspot groups. 1 formed, 2 rose. Look for the sunspot number to increase today. Here we've also included 171 angstroms. You can see all that activity, all those jumbled up magnetic field force lines over there in the northeast. Certainly likelihood of large flares coming from that area also. And once again, don't forget about this plasma bridge. You can see some of it happening right in here. There's a little bit of an exchange going on there. Plasma flowing back and forth between those sunspots across the solar equator. And those 2 sunspot groups are massive indeed. Let's take a look at energetic particles next. No spikes. Proton flux remains flatlined despite several M-class flares. Looks like at least 3 of them in the past 24 hours. That's your GOES X-ray flux over the past 3 days. And let's take a look at the best wavelengths through which to view solar flares. 94 angstroms is one of them. That's extreme ultraviolet light as well, by the way. You may have heard other channels who don't know what they're talking about tell you that that's the X-ray frequencies. And it's still ultraviolet light. And we have an M-class flare there right at the end of the video. Great imagery of that there, showing up at 94 angstroms. And we'll let that play through in its entirety one more time before we look at 131 angstroms. So a little bit of an increase here in the X-ray flux as active regions rise in the northeast. There's 94 plus 131 angstroms. And now that we've looked at all the major features here, besides coronal mass ejections and filaments, well, we did look at filaments a little bit. Let's take a look up at what's going on over Lehigh Valley. So, of course, we're always interested in that. We've got Mercury rising ahead of the sun. Also, a lovely crescent moon as we approach the January new moon. If you've got a low horizon and a clear sky, you might see Mercury rising ahead of the sun, especially if you've got low light pollution. And let's do a solar system forecast. Keep in mind this imagery is not to scale. It's from theplanetstoday.com. And we'll move this forward 1 week. We'll we'll have a crescent waxing moon by the 26th. And let's talk coronal mass ejections. So there's an interesting one. It looks like it did have some relativistic particles here striking the Soho-Lasco C2. You can see a bunch of blocks forming right in here. That is some relativistic particle matter there showing up at a very high rate of speed. That is associated with one of the flares, and the reason we don't see a proton spike in the GOES proton flux is because those never made it through Earth's magnetic shield. Keep in mind, those spacecraft at Lagrange point 1, they're not magnetically shielded. They're just orbiting the gravitational equilibrium point out there in space. In fact, some extra plasma gets funneled into that area just because of the gravitational effects. Anyway, that's yesterday's imagery. And if you're wondering if that CME is headed toward Earth, the answer is yes. Only a small portion of it, though. Anyway, that's today's imagery. That's additional 22 frames, and we'll show you an analysis here of the Earth-directed CME from stereo A and from Soho-Lasco C3 at Lagrange 1. So we paused it here at January 18th at 1553 and 1554. Because what we're looking at here is this filament eruption. See that on both images there. So from Soho-Lasco C3, that looks like it will miss to the south and west. Let's advance this a little bit to see that there is sort of a significant event happening here where you can see some ejecta coming out all around from the perspective of stereo A. So it's a partial halo ejection from the perspective of stereo A, which isn't too far from the Earth. So let's check and see what it looks like from Soho-Lasco C3. And we do see a partial halo there as well. So part of that CME is earthly directed. We'll let these play through here. Keep in mind they are not synced. Let me do my best to sync these. We'll start at 1442. So we can expect to see that CME arrive late in the day on, well, I should say early in the day on the 22nd, midday on the 22nd. So midday on the 22nd, you can expect a minor CME impact. That's midday universal time. And let's move on to show the 24-hour videos. So there's some great imagery of that. Again, that one CME that's mostly off to the southwest does have an Earth-directed component. It'll be a minor impact, maybe a KP4 or 5, depending on the magnetic fields at the moment. Here we'll zoom out. You can see the great relativistic particle strike there as well. Multiple relativistic particle strikes, actually. See all those blocks on the imagery? And here's the full zoom out. A little bit of relativistic particle radiation there. You could call it radiation. It's like little bullets, particles traveling at very high rates of speed, approaching the speed of light. Yeah. Sometimes we see relativistic particles show up all the way at the Earth as little as 20 minutes after a major solar flare. And again, no spikes in the proton flux there, as those relativistic particles likely made it to Earth's magnetic fields, just not down to where the GOES satellites are orbiting at about 22,500 miles of altitude. Anyway, let's talk filaments next. And we've got a huge number of filaments. Likelihood of coronal mass ejections remains nearly at 100%. This filament down here, named after me by Zach Tovin, is it's gotten bigger in the past couple of days, which could mean that it becomes more unstable. Also, as these regions down here are setting, the likelihood of their tendency to produce a flare is a little bit higher there. And again, don't be surprised to see major flares from the northeast or the southwest. Those are the two most likely spots. And also keep your eye on this area, because this sunspot down here is, I think it might be the biggest single umbra of solar cycle 25. And this sunspot here has the most number of umbra in solar cycle 25, I believe. Probably like 100 sunspots just on that sunspot group alone. Which brings us to our Name That Filament segment. Why? Because you're invited to follow us on Twitter. Yes, on Twitter. No censorship is not fixed. No, Elon has not repaired free speech. But nonetheless, you're invited to Name That Filament because there is no alternative to YouTube or to Facebook or to iTunes or to Twitter. There is no alternative. These platforms have billions of daily users. The rest don't, which means they're monopolies. Which means we insist that big tech organizations fix your software, or there will be repercussions, hopefully people going to prison over it. Anyway, follow us on Twitter, and let's take a look at the last couple of hours here. Again, check out this prominence up here. This is a spectacular prominence, and it's looking quite unstable here. That is the filament to name on Twitter. Dag. That is a big one. Maybe name it the Shaquille O'Neal filament. I don't know. What about we can't name it the Andre the Giant filament because it's named after living people. Anyway, here's the last 24 hours in SDO 171 angstroms before we move to bonus features. So let's blast through some bonus features here, and thanks for leaving a comment, Mike Bordages. So here's our bonus features segment. Satellite charging hazards. We've got some minor surface charging hazards here over the central Pacific Ocean, caused by low-energy electrons on the outsides of spacecraft. The GOES electron flux here, kind of low. It's about where we forecasted it yesterday. We expected it to be a little bit lower than a NOAA forecast, and indeed it is. So that's the last 3 days. There is the forecast model by NOAA for the relativistic electrons. And let's take a look at the 1 year graph. There it is in context. We're just in a moderated range here. It's pretty unremarkable. And we'll also take a look at the vibrational frequency of the ionosphere. We do it daily as we see the continued anomalies going on in the ionosphere. So this has been the most anomalous about 6 weeks that we've ever covered on the channel. We apparently broke the story about the South Atlantic anomaly moving into the South Pacific, and approximately 4 people are aware of that at the moment. Actually, all of our viewers probably are, because we mention it daily. The South Atlantic anomaly, now known as the South Pacific anomaly. For those of you who actually watch the content and immerse yourselves in the data and are not complete ignoramuses about what's going on with the planet and indeed the solar system. Anyway, let's bring up the latest image here. Switch to the anomalygram. There's the anomalygram. That's anomaly in megahertz from a 30-day median, and we're seeing quite a lot of high-frequency anomalies here, as well as some rapid swings over the central Atlantic especially. So some rapid swings to low-frequency anomaly there. High-frequency anomalies there dominating the northern hemisphere. And the latest image is 11:45 Universal Time. There's the ionogram showing vibrational frequency in megahertz, and there is the anomalygram showing anomaly in megahertz from a 30-day median. We'll also show the total electron content, which has been extremely anomalous. Huge GPS errors all around the planet. You can expect to see them continue here. If there are a lot of free electrons between your GPS satellite and your handset, your signal will be refracted, sometimes causing errors of thousands of miles. We've seen bike rides with average speeds of 10,000 miles per hour as a result of GPS errors. So there is your total electron content forecast, and huge anomalies happening here. I mean, unexpected GPS errors perhaps happening around the equator at nighttime. That is incredibly anomalous total electron content forecast. We show it every day. So our regular viewers are probably well versed in this. Those red areas are going to feature massive GPS errors. There are a lot of free electrons over your head if you're in those red areas at those times. Also, strange anomalies over the Caribbean with low electron contents. Also over southern South America, and some bands around, what is that? 40 degrees north latitude and 60 degrees south latitude. I'm talking about these areas right here. Those are strange global scale, low frequency, low electron content regions. Very odd. And frankly, we've never covered anything like this on the channel until the past couple of weeks. So this is sort of a new feature. Massive GPS errors there showing up in the total electron content forecast. Lots of electrons, quote, out of place, end quote. Next, how about the latest intensitygram and latest colorized magnetogram? Because again, we've got multiple new named sunspot groups. No less than 3 of them. Maybe even 4 of them. At least 1. There's 1 there, 2, there's 3, and there's 4. So as many as 4 new named sunspot groups there, rising and forming in the northeast. It has been an interesting time to be talking about space weather. And of course, I'm not some kind of noob to this. I realized back in 1994 when I took college astronomy that I needed to take a deep dive into heliophysics because of the implications on cosmology. So I didn't just sort of jump into the space weather game because of all the, part of the reason for making YouTube videos is because of all of the hack frauds who are unable to adequately cover space weather on the internet. So that's part of it, because there was no channel that created the material that we wanted to cover. So that the material that we wanted to watch wasn't there. So rather than whine about it, we just decided to create a channel at the Smash News Network, least busted name of news, and welcome to the Neo Renaissance. Assist us with clicks, if you don't mind. Click our links and go visit us on the interwebs. We've got accounts all over social media. Also a great merch shop. And don't forget the Smash team. Smashomash.com is the homepage, so join us on the interwebs, which is made of tubes, by the way. And if you want to support the channel via a subscription membership, consider becoming a member of the Smash team at the gold or silver level. The best value is the gold annual paid-up subscription, as it includes complimentary merch. It's like getting 4 months of gold membership free. There's also even a bronze membership for those of you unable and or unwilling to open your cobweb-encrusted wallets and send us a few bucks per month as we make just this side of nothing to put the content on YouTube, probably because of pathetic and putrid censorship by big tech organizations on social media sites. Again, there is no alternative to an organization like YouTube, which has a monopoly on video hosting. Yes, you can tell us to go to Rumble all you like. We might be able to make money there, but we will not have the capability of reaching 1 billion viewers per day. So consider becoming a member of the Smash team if you want to support the channel and increase the probability that these videos will continue to exist, remain publicly visible, and free for all to view. Of course, we've also got a merch shop if you weren't aware of that. Check out the links below the video to the merch shop. Great merch products there. Some of them are requested by our viewers. Some of them are just for fun. Some of them are to start conversations, and some of those are basic wisdom. Why did we decide to make merch? Because reasons. Actually, I wanted to give Smash staff a raise and offer some stuff besides just the content itself. Today's featured product is Smasher Price My First Scamdemic. Yes. So I'm currently wearing the Mensa hat, and part of the reason that our channel exists is to make Earth not suck again. We've noticed that throughout the past 3 years that there's been a lot of folks out there making Earth suck, even harder than it already has in many cases. And of course, in most situations, Earth is much better than it was even 10 years ago. So, yeah, it's Mensa. Make Earth not suck again. Do your part. And this is actually a re-release. So this is one of our first pieces of merch. And actually, I'm wearing it. So there you go. Mask the Earth. How's that working out? Is that working out well? Is it going to magically start work? Maybe it'll start magically working in 2023, folks. Who knows? Anyway, it's available on all kinds of different products. Get yourself a souvenir. And congratulations on surviving a global scandemic so far. You're doing a fine job. A fine job. And if you're a government official watching this video, we hope you're doing a fine job. And if you're anybody watching this video, fun fact, accountability always comes. Doesn't matter who you are, it always comes. And it comes one way or another. One of our first pieces of merch that we ever put out. We are also on Patreon. So if you'd prefer to support the channel that way, there are 3 different membership levels there. Once again, give Smash staff a raise by supporting the channel financially, because we will pour money back into the channel if we have some coming in. So press like, subscribe, share, etc. If you're new to the channel on YouTube, again, visit our links, check out our playlists. There are videos that have nothing to do with space weather and meteorology. So if you haven't seen those, drop by our playlists. And we've been doing live streams on YouTube the past couple of days just for fun. And let's move to meteorology. So here's part of our value-added services here, showing mean sea level pressure and surface winds are what those animations are. So that's the current situation. Some strong lows there around the Southern Ocean. And of course, regular viewers of our channel are aware that shapes are scary. So when it comes to planets and space and things like that, shapes are scary. So we've got a rectangle here. If you're looking for something to be frightened of today, well, there's a rectangle shaped low around the Southern Ocean. Maybe that'll frighten you. Not exactly sure. Alaska is surrounded by low pressure. Anyway, let's take a look at the wind patterns of the planet, as global weather patterns can give us insight into what's going on the planet. Anyway, these are the surface winds of the eastern world. Here are the jet streams of the east. Here are the jet streams of the west. Surface winds of the west are like this. It's windy on the Great Lakes at the moment. There are the surface winds of the central world, and there are the jet streams. And let's move on to get through the meteorology segment here. Here's our 3.9 nanometer infrared radiation satellite showing clouds and fog over the western world. It's too dark to use the visible satellite, and it is very cloudy and dingy outside at the moment over Lehigh Valley, Pennsylvania. Next, our weather.gov map. We'll briefly scroll down here to show you the key. If your area is lit, if your location's lit on the map, click your location on the map at weather.gov. It's a little bit too much to cover, but we will show some forecasts, such as your temperature anomaly forecast. So we've got some warm temperatures here in the northeast at the moment for the next 3 days, or at least for the next day or two. And some very cold temperatures, especially for the northern U.S. Rockies. That's a temperature anomaly in degrees Celsius based on the GFS model for the next 72 hours. We'll also show pressure and precipitation. Same model, GFS, same time frame, 72 hours. Pressure and precipitation depicted here. And we'll also show snow, since some of that precipitation will fall in the form of the white stuff. There's what we expect for the next 72 hours based on the same GFS model. We'll also show the Euro model, courtesy of windy.com. So here's the next 12 hours of expected snowfall based on the European model. Iowa can expect some heavy snow, especially in the western portion of the state. There is the next 24 hours as that snow moves into the Great Lakes region and into New York. And there is the next 72 hours. Some heavy snows coming to California and New England and the Great Lakes and Iowa and Kansas and Colorado. Windy.com, they've got a great mobile app. Check it out. It could save your bacon. What can also save your bacon is knowing where the lightning strikes are. And there were some thunderstorms there in Louisiana and Mississippi. Let's take a look at the real-time lightning map, courtesy of lightningmaps.org, to see if there are any terrestrial strikes. It looks like we had a strike in Lake Michigan there. just north of Summer Island there on this peninsula. Which is, wow, is that U.S.? That's U.S., I think. That is probably a desolate location indeed. No, that's in Canada. All right, that's in Canada. That makes a little more sense. No, that is not in Canada. That's the Upper Peninsula. Okay. Anyway, only one terrestrial strike in the U.S. Got some active lightning in the Atlantic and the Mediterranean. Also some in the South Pacific. Showing up there as we stream live. Anyway, we'll close things out with a U.S. Doppler radar map and some more imagery of the lower 48. So there's some real-time data for you as precipitation continues, as Alaska is completely encased in low pressure. Detroit seeing some snow at the moment. There is our shortwave radiation map showing clouds and fog, and there is water vapor. And we've got this nice little pulse here of dry massive air pushing that moisture out to the northwest. We've got some compression happening here as it collides with this high pressure system, creating massive pressure gradients in New England and creating precipitation as a result. Anyway, there is the U.S. Doppler radar map. There is shortwave radiation infrared satellite showing clouds and fog. And there is water vapor. And there is me signing off from the Smash News Network, least busted name in news. Thanks for tuning in. We hope you're not frightened of things that aren't scary in the slightest. And may that solar wind be at your back. Facts stated in this video suppressed for your convenience and online experience by criminal big tech organizations. Opinions stated in this video not necessarily the opinions of Smash News Network, least busted name in Nev.